Okay, continuing our discussion of arrays. Recall that when we declare an array, we have to specify a size of the array. So in this example, we have an array of type double. The square brackets tell us that this is going to be an array. We give the array a name. Then we have the equal sign, the keyword new, the type of the array again, and square brackets again. This time inside the square brackets, we specify the size of the array, also sometimes called the length of the array. We can easily retrieve the length of that array using the length field, which is provided to us by Java. So in this example, we give the name of the array, then dot length, and that returns back to us an int, which is the length of that array. So in this case, we get back a value of 25, which is stored in this variable called size. And remember, of course, that the index value of the first element is what? 0. And in this example, the last element has an index 24, correct. Now, another tool that we have to iterate through the values of an array is sometimes called the enhanced for loop. This enhanced for loop goes through all of the elements in an array and can make creating the arrays a bit easier. Here's an example of using first a regular for loop, then an enhanced for loop. So I'm using the same example that we just saw on the slide. We have an array of type double called temperatures, and its size is 25. This for loop initializes x to be 0, and x counts through all of the elements of the array. Note that we have the condition as being x less than temperatures dot length. That way, x will count from 0 to 24, and this tells us we're going to count by ones, the x plus plus there. And so it will count from 0 to 24, and for every element in the array, I just picked a value. We're assigning all of the values to 44. Okay. Now here is an example of an enhanced for loop. This enhanced for loop has a couple of tricky things about it. So should you choose to use this, you're of course not required to use the enhanced for loop, but it can make your coding easier. So the type of variable in the enhanced for loop has to match the type of the array. So since our array temperatures is a double, then our counter variable, it's actually not a counter variable, sorry, our local variable has to be of type double as well. And what it does is it actually takes on the value of each element in the array. So when we start out, it takes on the value of the first element, which has an index value of 0, which we know in this example is 44 because that's what we assigned it to. And it counts through the entire array. So let me go ahead and show what that looks like when we run it. So with the first loop, we're not going to see anything. It's just initializing all the values to 44. But the second loop will display all the values. So it displays all 25 values at 44. We'll make it a little more interesting. We'll make each value different by assigning it to, say, x times 2. So the value of each element is equal to 2 times of the index value. And that gets displayed here. So the new concept here is this enhanced for loop. So keep in mind, though, that the enhanced for loop doesn't provide a counter variable, whereas the regular for loop does. Okay, so that has some implications about which you should use when. Question?
Yeah, so you're declaring a double as temp, and then you have temperatures, you're calling in temperatures. So how is it counting up? Why is it? Because you didn't put plus plus at the end of temperatures, right? How is it counting? It's just going through all the index values.
Yes. So the question is, how is this enhanced for loop counting, how does it know what to count by? So what it does in the enhanced for loop is it looks at the array. The enhanced for loop, by the way, is only for arrays. You can't use it without an array. So it looks at the array and it determines the size of the array, and it will simply iterate through all of the elements in that array. It just counts through them. So you can't modify it to make it count by twos or count backwards or anything like that. It just iterates through the array in order. And that's all it does. And this variable here takes on the value of each of those elements as we're counting through the array. So the first time through, it takes on the value at index 0, the first element, which of course is 0. Second time through, it takes on the value at index 1, which is going to be 2, and so on. So it's not very flexible, but it can make your coding easier. It also greatly reduces the possibility of having an array out of bounds memory exception, because it will specifically count through the array that you give it. Okay, again, it's not required that you use this, but it can make your coding easier. It can reduce the chance of an error if you choose to use it. Any other questions on that enhanced for loop? So in this first loop, this is a regular for loop, which has to have a counter variable. So it has this local variable x, which starts out at 0. So it's 0. No, it has 0. The first element is 0. The second element is 2. The first element at index 0 is 0. The second element at index 1 is 2. Yeah, that's what I told it to do. I told it to take the index value and multiply it by 2 and store it there. Just to give it something different, not all the same number, just to show that, the array is storing unique values in each of the elements. There's no particular significance to multiplying it by 2. Any other questions? Okay. So here's another example that uses an enhanced for loop. In this example, we have a much smaller array, only 3 elements. Recall that when we use this style, this syntax for initializing the array, it also determines the size of the array. So we have this variable val, which is going to take on the value of each element in this array as the for loop iterates through the array. And so this will display each element of the array one at a time. So we'll see 3, 6, 9 if this program were to run. Good? So recall that the array size is 1 more than, as we've gone over, the array size is 1 more than the index of the last element in the array. So that's why if you're going to use a regular for loop and you want to iterate through all the elements in the array, you need to start at 0 and end at 1 less than the length of the array. So this built-in functionality, this length field, is available to any array, and it makes for a useful tool in determining how many times a loop needs to repeat if we were going to iterate through the elements in an array. You can also let the user specify the size of an array. And this is the main reason why Java provides the option of declaring the array in one line, but then determining the size of the array in a separate line. So that is another option with the syntax for creating an array. So if we look at this example, display test scores.java. Here we have in this line the array being declared. In this line, we have an individual variable of type int being declared called num tests. Then we ask the user how many tests they have. We get that input from the user, and we use that value to determine the size of the array. So this line takes our array tests and determines its size. Then, based on that size of the array, we use a for loop that will iterate through the elements in that array, each time getting a value from the user and storing it in that element in the array. So the user's determining a lot here. The user's determining the size of the array, which therefore determines how many times this loop repeats, which also will determine how many times this loop will repeat, which will iterate through the array and display all those values. So let's go ahead and run this program. Okay, how many tests do you have? Give me a number. 4. Give me some test scores. 110. Okay, and there you have it. It displays the numbers. Okay, so the takeaway here is not that we're simply reading and displaying numbers. That we already know how to do. The takeaway here is that the user determined the size of the array, and then these loops first stored values into the elements of the array, and then later displayed those values. Okay? Yes?
How does the tests dot length, how does that affect the user inputs? Like, how does it affect
So we asked, so the question was, how does the tests, how is test.length linked to what the user inputs? So what happens is, we ask the user how many tests, right? We store that value in this variable num tests. Then in this line, we determine the size of the array based on that value num tests. Okay, so the user indirectly determined the size of the array. Once that's established, that becomes a property of the array that we cannot change. That size of that array is fixed, and we can retrieve the size of that array with this dot length field, which is a built-in part of Java. Okay? Good question. Any other questions? We can also reassign array references. So something to understand that's fundamental about arrays is that they're a little bit different from the primitive data types by themselves in the way that they're stored. An array name is really an address in memory. So if we were to assign an array, say to have a size of 10, and then later reassign the array to have a size of 5, we actually can do that. It's allowed, but whatever was stored in the array before would be lost. It'd be garbage collected. In other words, if we had an array with 10 elements and those 10 elements had values, if we went ahead and reassigned the array to now have 5 elements, we don't just lose the last 5 elements, we lose all 10 elements. Okay? It's like creating the array again from scratch. And that first array is lost. You could increase the size, the same thing would happen. If you started with an array of size 5 and then say reassigned it to size 10, whatever was in the array before would totally be lost. You're creating a brand new array. It's pointing to a different location in memory. Okay. So this is a visual of what's happening. The array name is essentially an address in memory. When we establish the size of the array, it's pointing to one particular address, which is set aside to hold the number of elements that we specify. One way to think of this is that an array is an address and then an offset. So the address points to the array, and then the offset is the element within the array. So a 0 offset is the first element, 1 offset is the second element, and so on. If we were to reassign that array reference by changing its size, the address changes. It's no longer pointing to that first array, that first place in memory that had 10 elements in it. It's now pointing to an entirely different location in memory, which takes on the size of whatever we specify. Even if we reassigned it to be the same size, this would still happen. The old array would be gone, would be garbage collected, and we'd have a brand new blank array.
Say garbage collected, does that mean it's going to be reused somewhere else? Or you would have to wait till you shut down, restart, and reinitialize?
So the question is, what happens to the so-called garbage that's collected? My understanding of how Java handles that is that it periodically, while the program is running, goes through to see if there's any memory that was previously allocated but is no longer being used, and it frees up that memory to be used later. So this also happens when you have a local variable. If you have a local variable in a method, once the method is over, that data goes to the garbage collector. It is possible, if there's some sort of error such as a memory leak, that that data could somehow be picked up by something else, some other part of the program or a part of another program that's on your system. But that would be a malfunction. That wouldn't be the way it was designed to operate.
When it collects the variables for the array, does it have to be sequential?
It does them all in one shot because they're all. So the question is, when it collects the variables, the elements in the array, does them sequentially? It doesn't really work that way. It does it all at once because it's one address that's pointing to all the elements. So just by basically doing away with the address, all of the elements just kind of go away. Great questions. Sometimes we may have the need to copy an array, which probably means that we want to copy the data in the array to another array for some purpose. Now, we may be tempted to simply assign one array to another array with a single equal sign or assignment operator. And this is fine for primitive data types, but this causes a problem with arrays. The reason why is because, again, the array is an address. So if we assign an array to another array, what happens is the addresses become the same. You essentially end up with one array that has two different names. So in this example, we start out with array 1. It's being assigned these values, so it has a size of 5. And then we assign array 2 of the same type, also an int, to take on the address of array 1, which means that they essentially become the same array. So throughout the rest of that scope, whenever we change the value of an element in array 1, that therefore also changes that value in array 2. They are essentially the same array. So this example shows that. So here we have, just like in the slide, array 1 takes on these values, which also gives it a size of 5 all in one line. Then we assign array 2, which is also of type int, to be equal to array 1. And what this example will show is that if we change the values of the element in array 1 or array 2, it's changing the same array. Both array names are pointing to the same place, so they're both changed. So go ahead and run that. And so at the bottom of this, we have two enhanced for loops, one of which is counting through array 1 and displaying the values. The other one is counting through array 2 and displaying the values. Notice that the output is the same. Okay, so here we changed one of the elements in array 1. Here we changed one of the elements in array 2. But because of this assignment, they're the same array. It changed both with both assignments. Questions on that? So with that in mind, let's say we really did need to make a copy of an array. How do you think we could go about it? Clearly, this is not the way to do it. What's that?
Keyword copy.
Keyword copy. I don't believe so. I don't believe there is a keyword copy for this task. Yeah.
You can copy and paste the bracket 2, 4, 6. I don't know if that's the most efficient, especially if they're long.
Oh, so okay, so you could initialize the second array to have the same contents, but that's not the question. The question is we want to make a copy, not create another array that happens to have the same values. We actually want to copy the values from one array to the other. Yes, copy the individual elements, right? So basically you'd have to use a for loop. Well, you could use other types of loops, but the best way would be a for loop to iterate through the elements in the array and one by one copy the elements from one array to the other. So this next slide shows an example of that. Here we have first array given these values. Second array, very important, second array is of the same type, has to be the same type or else this won't work. And also the size of the array has to be at least as big as the first array, right? In order to hold all the elements. Otherwise we'll get an array out of bounds exception. In this case, we made them both the same size, which makes sense. We have our for loop. Our local variable I is our counter variable, starts at 0, and it goes to, again, 1 less than the length of that first array, counts by ones. Each time the loop repeats, we assign an element from second array to take on the value of that corresponding element from first array. Okay, so the first time through, we have second array sub 0 is equal to first array sub 0. In other words, second array becomes 5. Second time through, second array sub 1 equals first array sub 1. In other words, it takes on the 10, and so on. Questions? Good. We can also pass arrays to a method. The syntax is similar to when we were passing individual primitive data types to a method. However, the key difference is that when we pass an array to a method, we're actually passing by reference. In other words, we're passing the address of the array. So we talked a little bit about this before when we were dealing with strings. But with strings, if we changed the local version of that string, it did not affect the string back in main. With arrays, it does. So if we change the value of an element in the local version of that array, it will also change that same element back in the array that was passed into it, back in main. They're pointing to the same place in memory. Let's look at an example. I think that will help to solidify this. So pass elements. And by the way, these code samples are part of the textbook. There's a pass code that's provided with your book. You can go to the publisher's website and download these examples yourself. So here we have an array of type int. It takes on these values, which also determines its size. Here we have a for loop, which is going to call show value. So all this does is it passes the elements one at a time into this method and the method displays them to the screen. So there's no print statements in main. The print statement is in the show value method. And this just shows how we can pass elements one at a time. Okay, so there they are, all displayed correctly. Now, if we pass a whole array, that opens up some interesting possibilities. So let's look at the example pass array. In this example, we have an array of size 4 of type int. It's called numbers. Then we call this method getValues, and we pass in, the syntax is very important here. Notice we pass in numbers, no square brackets. What that means is we're passing in the entire array, essentially the address of the array. So we're not passing in an individual element. We're passing in the whole array. Now let's look at this method getValues and check out its syntax. Here it is. So the header of getValues, very important. We have the square brackets here. So it's int square bracket space array. What that means is this method is expecting an array of type int to be passed in. It will not accept an individual variable. It has to be an array. And we named it array. So the local name of this array is simply array within this method getValues. Because arrays are passed by reference, that is the same memory location as this array numbers from back in main. Or sorry, I'll look at this method call, it's clearer. This array numbers from back in main. They're pointed to the same place in memory. So what this method does is it prompts the user for the values in our array and stores them in this local array index. Keep in mind that this local array index is in fact the same array as numbers back in main. So changing these values locally also changes them back in main. Then we have another method, showArray, which we also pass the entire array to. This array doesn't make any changes. It simply displays the elements one at a time to the screen, again using a for loop. So let's go ahead and run that. Give me some numbers. So there you have it. It displayed the numbers correctly. So again, the takeaway here is not that we read in numbers and printed them out. We already know how to do that. The takeaway here is that we're doing it using an array, and we're doing it by passing the array by reference into a method. So when we were doing some of the group projects, a couple of students asked, how can we pass more than one element back from a method? And the answer was you can't, but you can come close to that functionality through this approach. You could pass an array and then change the values of the elements in the array as shown here. And as we saw, that changes the array back in main. Now there's some limitations there, right? An array can only hold one data type. So if we needed several ints to somehow make their way back to main, this would be one way to do it. But if you needed mixed data types, an int, a char, a byte, this approach would not work.
But since we're learning that the array is of one common type,
Mhm.
you could have one method to pass char, pass doubles, whatever.
That's true. So the point that was brought up is that we could pass multiple arrays into a method, right? So yeah, you could do that. You could pass multiple arrays into the method. Each array could be a different type. So that would be a way to get data back to main of different types if you needed to do that. Very, very good points. Very good questions. Any other questions? All right, let's break it up a little bit. Let's look at a gadget. So I found this quick video on some smart home gadgets. So why did I show you that?
Do you like the crock pot?
You figured me out. I want a smart crock pot. How is it relevant to programming? How is it relevant, in fact, to arrays that we're learning right now?
Please store data.
All these devices need to store data somewhere. You need to read data, manipulate data. Take the example of the thermostat. One possibility there is that we could have an array that stores your desired temperature, say for every half hour or every 15 minutes. And then it would read those data from the array and adjust the thermostat accordingly. I think you can extrapolate on that and see how this applies to each of those devices. What do you think of those devices? Are any of them new to you? Did you know those things existed?
Some type of idea that some of them might be. It's definitely interesting to see that. It's hard to just go out to Walmart and find that stuff laying around.
Yeah, I'm not sure you'd find these at Walmart because most of them are pricey. But I know Home Depot carries a lot of this stuff.
I like the smoke detector because we always, when I used to cook pancakes when I was little, and now when we're cooking sometimes, something will smoke up and then you gotta go, it's up on the wall and you just put a broom in front of it to wave it to stop it from beeping or go up and take the batteries out. And then you gotta put it back in before you get a real fire. I think that's pretty smart to have a smart detector. Maybe you can pull up your phone and say, no, it's just and then it goes off in another 5 minutes and resets.
Okay, we got one vote for the smoke detector because there's some intelligence there, so it can maybe ask you, hey, did you burn your food before it actually goes to red alert? Control it with an app, presumably.
I'd rather just go right straight to the firehouse.
Y-
Dispatch center.
So you'd rather not have a smart smoke detector. You'd rather have a dumb smoke detector that just goes straight to the firehouse.
What happens if you bring your food and then the fire department says you go back to
Just start coming and then you get canceled and you turn around and go back. That happens a lot.
Okay. Do you work for the fire department or
Yes.
you do? Okay. So do the firemen get annoyed if it's the same person over and over again? I mean,
Not really, no. It's pretty common.
okay.
Usually, one vehicle takes and goes to the scene just to verify, and everybody else goes back to the station. But I think if you had something going and it's sitting there waiting to ask you, you're losing way too much time to evacuate.
unless they built in
But
like a 10-second timer. You have 10 seconds and they say, is it your food burning? You have 10 seconds to get to it. You have not. Then it's
yeah, I assume there's a time limit, right? So it's good. So the smart smoke detector says there's smoke in the air. Did you just burn your food or is this more serious? And if there's no response in some short amount of time, 10 seconds, maybe 15 seconds, then it goes to full blown red alert. So that, if there really is a situation or the person is unable to answer, that's obviously.
I think the way I picked up of the one that was on the video is you actually had to have visual movement in front of it, what the lady was doing.
Oh, okay.
So, I mean, that kind of makes more sense. At least they're aware that there's smoke and they're trying to stop it.
Hmm.
Rather than being on the ground.
I'm not sure the exact.
Trying to stop that.
Yeah, I'm not sure the exact mechanism. Whether you have to have your phone or you talk to it or you wave your hand, I'm not sure. Um, Regardless, there should be a time limit, right? If there's no response in some amount of time, then it has to go to red alert. What do you think of that as an expert? That you're the class expert.
I'd rather go straight through.
You'd still rather have it go straight through.
It's fire doubles 10 times in the first 5 minutes. So if you've got something that's big, you're going to be the entire room.
So the fire doubles in size every 5 minutes.
It doubles 10 times in the first 5 minutes.
It doubles 10 times in 5 minutes. So
So if you have
so it grows exponentially.
small pot or something, by the end of 5 minutes, you have the entire room. If you're in a volunteer fire district, you've got to wait for people to go from their home to the firehouse, get on the truck, drive back to the scene, put the fire out.
I see.
Probably already lost the building.
I see. Interesting. So I actually personally didn't put a smoke alarm in the kitchen for that reason. I have one in every other room, but not in the kitchen. Is that a bad idea?
Not necessarily. It depends on how your home is laid out.
Okay.
I don't have one in my kitchen, but I've got one in the mudroom coming into the kitchen.
Yeah.
I've got one in the family
Yeah, as do I. There's one in every other room, just not in the kitchen.
When you lose time, because if you smoke, not, if you do have a fire in the kitchen, and the smoke is in the kitchen, and then it takes so longer to get out, well, every 5 minutes it doubles 10 times, right? So we can lose the same amount of time as if you had
What was that?
We turned off in 10 seconds. Right? When you
Not
get that
necessarily.
22,
Oh, if the doors are shut.
longer,
Yeah.
it's gonna take-
Okay, we're getting a little bit off topic.
Okay.
What do you think of the other gadgets on the list? Somebody's gonna go get the crock pot. You can have it connected to your Jibo. How about that? From yesterday.
I think that the locks are pretty unsafe, honestly. I don't like the idea of having a computer controlling how people get into my house.
Well, I mean, you also can have the regular lock too.
Well-
It's kind of like double security.
Yeah, I know, but the thing is, what if if a person knows how to hack the lock on the door, they probably know how to hack the alarm system in your house.
Okay, so a couple comments. So you're saying that if you have an electronic lock that doubles your security, I have to disagree, because these locks are designed so that all you need is your smartphone or something to get into the house.
But said you could just put it right over someone.
Yeah,
Over
it's
your
a-
deadbolt.
You put it over the deadbolt, but what's happening is that it's providing an electronic interface that physically moves your deadbolt. So it's not double security.
I thought it was just extra security.
It's not extra security. No, it is. The idea is keyless entry. That's what this is for. So, and these things need to have power to work. They're usually batteries. Yes, but I don't know the details though. How often you need to change the batteries? Uh,
Well, then you probably just use the regular lock.
okay, you could just use the regular lock if that happens, but then you're back to having to carry a key as well.
Yeah, I'd rather carry a key.
Well-
I feel like it's safer.
In vehicles.
These are also quite expensive. I was just looking at the prices of these smart locks. They're around like $200 each.
As far as the power is concerned, in vehicles, say your key ring dies, you can't hit your button to unlock your car. For most cars nowadays, use it to start your car. There's an exciter within the car, so you just put your key fob near the exciter and it automatically gives it power so you can operate your vehicle. So I imagine you put an exciter near that door lock to always have power.
Oh, so wireless charging for your key fob.
Exactly.
Okay. That's possibility. I just added wireless charging to my cell phone. So yeah, you could have a wireless charger by the door. But then where does it get its power?
Well, through the wall, of course. I mean, it'd be a direct link into your.
So these are wired? I don't think most of them are. I think most.
The lock itself, whatever is moving on the door would be wireless, of course. And then the inside portion where the exciter is, obviously is sitting inside your wall and your door jamb. So you can run your power.
Oh, so the wireless charger is connected to the house power. Interesting.
Yeah, it seems logical.
What if there's a power failure? Yes.
One of the places, well, the place where I work, he gives us a fob. It's a storage facility, and we have studios and stuff. And so everybody gets a fob who goes into the building, and he programs each of the fobs as they give you one. They program it, and they can give it a number and everything. And they can tell. First of all, they can tell when you entered what room with what fob, so they know where everyone is. In case we've had people try to come in and steal stuff. So we say, we know it was stolen between these 2 hours. We have all our cameras. So we say, well, it must have been, when we look at the fobs and who accessed the building, and we can actually track people who tried to steal something from the storage facility. And also, you only have one key, and it can be programmed to unlock only certain doors. So if you don't want someone going in, you shut down the key and they can't get in.
Yeah, so you brought up the point of these being programmable. That's the major advantage to these smart locks, is that they're programmable. So for example, in terms of a residence, if you say you have a contractor working on your house, you could set up a pin that only that contractor knows, and then once the job is done, you could actually erase that pin from the smart lock, and so it no longer works after that. So to me, that's the primary advantage of this technology. Not sure it's worth $200 for most people, my opinion. But anyway,
What happens when you have all these systems broadcasting? Would you end up with data collision, stuff like that going on?
all right. So the question is, if you have all these systems broadcasting, do you have data collision? The amount of data we're talking about is extremely small, very, very small.
You get a toaster, a prop, thermostat, all that.
Yeah,
You start talking about electronic homes.
right. So you have a smart home with multiple appliances all sending data. Even still, the amount of data we're talking about is very, very small. You know, something like a temperature or whether something is on or off. We learned about how much data that is. It's very little. We're talking about a byte, for each device. Even if it has 100 of those, okay, we're talking 100 bytes. That we're talking, well less than a megabit of traffic. So, so yeah, there is a security risk potentially.
Somebody wants in their home, they're gonna get it.
Yeah. Okay. Getting a little bit off topic. Let's move on. So comparing arrays. So similarly to assigning arrays, we may also be tempted to compare arrays directly using this double equal sign comparison operator that we can use for primitive data types. The problem with this, though, is that recall that the arrays are actually addresses in memory. So if we compare two arrays, even if they have exactly the same contents, this comparison will always return false because the arrays are not stored in the same location in memory. What is the one exception to that?
Building is one index.
No? If we previously assigned one array to be equal to the other array, okay, then those arrays are pointing to the same memory location. They're essentially the same array. So that's the only way that comparing the two arrays would return true, is if they were pointing to the same address in memory. And we use the assignment operator that we saw in the previous slide. Other than that, this will always return false, regardless of the contents of the array. How are we doing on time? We're done. Thank you very much. See you tomorrow.